So we are going to solve a problem that has appeared in Jee Advanced. This is a very important problem that is actually a mangle of algebra and calculus and concepts of limits. This is a very nice problem, that's why I've taken it. So this is in the series of Jee Advanced compendium of differential of definite integrals. So let's solve it. So we are going to solve it. So let's begin with the solution. Here we can see the pattern. This is 16 and 32 and 48. So I'm just writing 16, 32 and 48. These are actually multiples of 16. Okay, these are multiples of 16. Similarly, this 5n and n and 3n, so 5, 1 and minus 3, they are in AP with common difference minus 4. Okay, so that's what we can see the pattern. In denominator we can see that this is 4n, this is 8n and this is 12n. They are multiples of 4n. Okay, they are multiples of 4n, and we can see that this thing is constant in every term, so we don't need to pay that much attention on that. Okay, so using that we can write this as f of n is let me speak about this also. This is n, this is additional given, and this will certainly came into use when we solve it. So f of n is, we can write f of n as n plus, and by the pattern we observed we can write this in the form of summation. So this can be written as sigma, and this is because 16, 32 and 48 are multiples of 16, so we can write 16 into r. Okay, and these 5 and 5n and n and minus 3, and they are in kind of AP, so we can write that like 9 minus 4r into n. Okay, and this is 3n square is common everywhere, so this is minus 3n square, and in denominator we can see this summation is in both numerator and denominator. So in denominator we can see that 4n, 8n and 12 are multiples of multiple of 4n, so we can write 4n into r, and this 3n square is common in all, so r from 1 to n. Okay, you put 1, you get this term, you put n equals to 2, you get this term, you put n equals to 3, you get this term. So that's how we can write this. Or we can also write it in, we can take n common, because we can write this as summation of 1 from 1 to n. Okay, so this is actually n. Okay, so we can also take this common, so and we can write f of n as this. F of n is sigma r equals to 1 to n, and this is 16r plus 9 minus 4r n minus of 3n square divided by 4nr plus of 3n plus of 1. This because we have taken this n into common, so we can take LCM, and we can write this as, when we will take LCM, this will become minus of this will become plus of 4nr and plus of 3n square. Okay, and when we'll open this, we'll and when we can see that some terms are cancelling. This 4nr is cancelling here, this is 9n, and this is 3n square, 3n square is cancelling here, and this is 4nr, and this 4nr is cancelling here. So we are getting, ultimately we are getting sigma r equals to 1 to n, and in numerator we are getting this 16r, and only this 9 into n, and this n is left here, so 16r plus of 9n, and in denominator we have 4rn plus of 3n square. Okay, now we are asked to find, this is fx. Now we are asked to find limit f of, this is f of n, we are find limit n tends to infinity. Okay, of f of n, so this is limit n tends to infinity, summation of this upon this. Okay, and we know we can convert this limit in the form of integration. For that, what we want is, we want for that we'll take n common, So if we'll take here n common, we can write it as n into 16r by n plus of 9. Let me write it here. So we can write this as a n outside, and there is 16 r by n plus of 9. In denominator we can take n square common, and we can write 4r by n plus of 3n plus of 3, and this n square cancels here, and this is actually limit n tends to infinity. Okay, and using the ideas of integration as a limit of sum, we can write it as from 0 to 1 limit, and this and r by n is treated as 16, so this is x, so this is 16x plus of 9, and this is, because this is 1 by n, we can write 1 by n is treated as dx, so, and this can be written as 4x plus of 3, and here is dx. Okay, now we can see that if we add here 12 and subtract 12, we can get this as a multiple, we can get its multiple in numerator, so we are going to do that. So we are going to do from 0 to 1 16x plus of 12 minus 12 plus 9 upon 4x plus 3 into dx. This is 0 to 1, and this thing is now 3 times multiple of 4x plus 3, so we can simply, let me fix the camera first a little bit. Yes, so we can simply write 3 times 4 4 times of, so we can simply write 4 dx for this particular thing, and we can write minus 0 to 1 3 upon, and we can write 3 upon this thing, that is 4x plus 3 dx. Okay, then this thing comes here as 4 into x limit 0 to 1 minus of 3 by 4 ln, we can write as 3 by 4 ln 4x plus 3 limit 0 to 1, so this becomes 4 minus of 3 by 4 ln, we will put limit 1, so this becomes 7 by 3. Okay, so that's our answer, and we can see from this we have the option number B is the answer. Okay, so that's our answer. That's a very beautiful problem, so I think it would help you. So like, share and subscribe, and for more questions of Jee Advanced, subscribe my channel. Thank you.